Hello and welcome. We're going to be looking a little bit at a new topic here in our science class, a little bit about work and efficiency. We've been talking about energy, and you were looking a little bit with some simple machines before. So when we talk about work, work is talking about the transfer of energy by a force, and it's applied over a distance. So you got the two main components there. You got it dealing with some force, some push or pull on an object, and it has to be going over a distance. So it has to be some sort of movement involved. If you're just like holding an object in place, it might be sort of difficult work. But if you're not actually moving it any distance, it wouldn't actually classify as work. It might require effort. It might be difficult, but it's not work. So if I look at a little picture here, which or who has done the most work? Work is force times distance. So you got the two people pushing large boulders, both with 500 newtons worth of force. The boulder on the left there is 300 kilograms. The one on the right is 100 kilograms. And the one on the left, there's no movement. The one on the right goes 6 meters. So the one on the right would be doing more work because it's actually moving that boulder 6 meters. Versus the other one, the boulder doesn't move. They're pushing. It's difficult, but they aren't actually moving any distance. That wouldn't classify as work. So you have to have a force applied over a distance. Another key idea that you might see occasionally is that if you're lifting something, the work done lifting is going to involve the weight. So if you lifted a box that was 50 newtons, that was the weight of it. As you lifted it 2 meters, your force would be 50 newtons, the weight of that box that you're overcoming, and that distance would be the 2 meters you lifted it. So whenever you're talking about raising something, it's always dealing with whatever the weight of that object is. If we want to find some things using our work, if we wanted to find, let's say, work, it's going to be the force times distance. W work equals force times distance, and it's going to be measured in joules, just like our energy was measured in joules. Another thing, if we wanted to resolve that equation, if we wanted to find force that was involved in work, force would be the work divided by distance, and the force is measured in newtons, as it always is, as it is throughout when we've seen it. And the last thing, if we wanted to find distance involved in our work, it would be the work divided by force, and distances would be in meters. So hopefully, as we're going along here, you might be pausing things to give yourself a moment to actually write this down and put it into your notebooks. Example one, if we want to look at an example here, how far does a 100 Newton force have to move to do 1,000 joules of work? If you wanted to pause quick and try to figure that out on your own, that'd be a really good idea. We're looking for how far, that's distance out of those three equations we just wrote down. We'd be looking at distance equals work over force. So our work would be the 1,000 joules. The force would be the 100 newtons. So we're doing 1,000 divided by 100. And you could probably figure that out on your own, or if you used a calculator, you'd get 10 meters because our distance is in meters. We're looking at another example dealing with work. How much work is done by a person who pushes a cart with a force of 50 newtons if the cart moves 20 meters in the direction of the force? So we got a distance of 20 meters. We got a force of 50 newtons. We're looking for work. So if you glance back, the equation for work is work equals force times distance. So our force is 50 newtons and our distance is 20. So we're doing 50 times 20. Multiply those together, and that would give us 1,000, and work is measured in joules. Not too bad there. Another part, if we want to look at efficiency, you're talking about like simple machines or other devices, efficiency, we're going to be dealing with energy that's going into a system, energy or work going into a system, and our energy or work that's coming out of the system. And some part of that system, that process, that machine whatever is going on, you typically have some loss due to friction or other things. We've talked about energy transfer into heat as things go along and such. So a lot of time you're not getting as much out of a machine or a system as you put into it. And that's what efficiency is dealing with. It's a comparison of that work output of a machine or a system to the work input that you're doing. So talking about like the work that you put into it or the operator puts into a pulley or into a inclined plane or something like that versus how much work is done out of that machine. So that work output is talking about the work or energy that comes out of our process. What's the result after you've used your machine? And the work input is the energy or the work that's supplied to the process, usually what's put in or what the operator supplies, what they're doing. And an important note is that our energy output, the amount of energy you can get out of our process or our machine, can never exceed the energy input. That's our law of conservation of energy, that energy is neither created nor destroyed. We're not going to get extra energy coming out of nowhere. If you did develop something like that, that would be a perpetual motion machine, and you'd probably be really, really rich if you figured out a way to get more energy out of something than you put into it in the first place. That'd be pretty impressive. Equation wise, we just got one here that we're going to deal with. If we want to find efficiency, efficiency is going to be our work, the output divided by the work input times 100. And it doesn't really have a unit so much as it's a percentage. So your unit would be percent. So let's give you a moment. You can pause and write that down. Then we'll move on to an example quick. Our third example here for today's lesson. If we're looking at efficiency, let's say you do 32 joules of work using a pair of scissors while you're cutting up, I don't know, a piece of string for some reason. I don't understand why. And that scissors, they're doing 25 joules of work when they're cutting a piece of fabric, I guess, instead of string. What's the efficiency of the scissors? So if you're looking at that efficiency equation that we just wrote down, it's the work output over work input times 100. So the output, that's what the scissors are going to do on the fabric. The input, that's what you are doing to the pair of the scissors. So the 25 joules would go on the top there, the 32 joules on the bottom. We divide those, multiply by 100, and that would give us, when we round it to the nearest percentage, about 78%. So those are work and efficiency, nothing too complicated there. Yeah, take a look at that. If you have questions as you're going along, you can ask, I suppose, and you probably have an assignment to work on now.